In this video, we're going to look at a problem called Farmer Bob's Garden Task. And this is kind of a combination of some of the things that you've learned about adding together polynomials and multiplying them together and collecting like terms. So we have Farmer Bob's garden here. He's planting squash and pumpkins and corn and beans and potatoes. And it says his plan for the field layout in feet, that's our units, is shown in the figure below. Use the figure and your knowledge of polynomials, perimeter, and area to solve the following. So remember, with perimeter, we're talking about the distance around a shape, and that's when we add the polynomials together. And when we're talking about area, we're talking about the total surface inside the perimeter, whatever that shape is, and we multiply the polynomials together. So the first thing we're asked to do is to write an expression that represents the length of the south side of the field. So they gave us a little compass here, north, south, east, west, to remind us which direction is which. So the south side of the field would be down here. So we have this length, and this length. If we want the total length of the south side of that field, we need to add those expressions together. So we have 5x plus 2 plus x squared minus 9 plus x squared minus 7x plus 12. And then after that, we're asked to simplify that polynomial expression. And simplifying is another word for, in this case, collecting like terms. So we want to collect our x squares. We have x squared plus x squared. That's 2x squared. Then we have 5x minus 7x. That's minus 2x. And then we have 2 minus 9 plus 12. So 2 minus 9 is negative 7. And then when we add 12, we get positive 5. Now we're asked to write a polynomial expression that represents the perimeter of the pumpkin field. So first we have to find the pumpkin field. There it is. And we want the perimeter. Remember, the perimeter is the distance around. So we're talking about this distance here. And there's a little added thing we have to do here, because they tell us this side of the pumpkin field and this side of the pumpkin field, but they don't tell us this side or this side. But we are assuming here that these are all rectangles. So we know that if this side is 5x plus 2, then this side is also 5x plus 2. And if this side is 5x minus 2, then this side is also 5x minus 2. So now we can write the expression. We have 5x minus 2 plus 5x plus 2 plus 5x minus 2 plus 5x plus 2. That's our perimeter. But then, of course, they ask us to simplify that expression. So again, we want to collect like terms. So we have 5x plus 5x plus 5x plus 5x. Well, 5 plus 5 plus 5 plus 5 is 20. So down here we have 20x. And then we have minus 2 plus 2 minus 2 plus 2. Well, those are zero pairs. 2 minus 2 is just 0, and 2 minus 2 over here is just 0. So actually the 20x would be our final answer. If you wanted to write plus 0, you could, but it's not necessary really. It says, state one reason why the perimeter would be useful to Farmer Bob. Well, think about it. This represents fencing, right? So he needs to know how much fence material he has to buy. So whether it's the pumpkin field or the entire perimeter, he needs that number to be able to go to Home Depot and buy his fence. Now we're told to write a polynomial expression that represents the north wall of the potato field. So let's find the potato field. That's the one right here. And the north wall, remember our directions over here, north is in this diagram up. So the north side of the field is going to be right here. And And we know again that this is a rectangle, so if this is the south side of the field, then this is the same as this. So if we want to write a polynomial expression for that, we can just write x squared minus 7x plus 12. Then they ask us to simplify the polynomial expression. Well, we have an x squared term. Do we have another x squared term? No. An x term, but we don't have another one. And then we have a constant term with no variable, but that's the only one. So really, the simplified version in this case looks exactly the same. Now we're asked to write and simplify the polynomial expression that represents the area of the bean field. And then they give us some additional information. This is why you got to read the whole problem, because they say if x equals 3 and y equals 7, they actually give us those values. And then they ask about the units at the end. So first of all, we're talking about area, and we're looking at the bean field. So let's find the bean field. There it is. Okay. And we have an expression for these two sides of the bean field. And when we're working with area, we're going to multiply those expressions together. Now, we're going to pretend they didn't give us the values for x and y to begin with, just to review how we multiply those together. So if we create an area model, you guys have been doing this. You did it with algebra tiles as well. And this is no different. Then we're going to put our two factors here. We have xy minus 1, and then we have xy plus 1. So when we fill in this area model, because we're looking for the whole area of this region now, when we fill it in, we get xy times xy is x squared y squared. Then when we multiply negative 1, let me make that negative a little bit bigger so we don't forget about it, we get negative xy. Then when we multiply xy times 1, anything times 1 is just itself. Then when we multiply 1 times negative 1, we get negative 1. So remember to get each of these elements in each of the squares of the area model, we're multiplying. But at the end, we're going to add all those things together to get our final polynomial. So we have x squared, y squared, minus xy, plus xy, minus 1. But again, we have a zero pair here. We have xy minus xy, zero pair. So all we have left is x squared, y squared, minus 1. Now, we're told that x equals 3 and y equals 7. So since we've gone to the trouble of multiplying this out, we could have actually put the values into the factors to begin with and just multiplied those two together. But since we've gone to the trouble of doing this, let's use that final polynomial, x squared, y squared, minus 1. And let's put the x equals 3 and the y equals 7 in for those values. X equals 3 goes here, and the y equals 7 is going to go here. So we end up with 3 squared times 7 squared minus 1. Well, 3 squared, that means 3 times 3 is 9. 7 squared, that means 7 times 7 is 49. And minus 1. 9 times 49, you can put that in your calculator, is 441. Minus 1 gives us 440. And then our units, because we were told in the beginning that we're talking about feet, but we've multiplied these together. We've gotten an area, which means our units are going to be squared. So we have 440 square feet.